All right. In the last video, I talked about interval notation and looking at some inequalities and compound inequalities. But here I want to take a little bit further look at compound inequalities and absolute value inequalities concerning chapter 1.6 in our book. A compound inequality consists of two inequalities joined by the words and or the word or. So let's take a look at what an and compound inequality looks like. Well, here's what we would consider an and compound inequality. In other words, 3y minus 7 is between 8 and 23. And notice here that it's in between those two. So let's take a look at that on a number line real quick. Let's just see where 3y minus 7 would be on a number line. So we get our number line here that goes all the way in both directions. And here's 0. And here's 8. And over here we have 23. So somewhere between 8, not including 8, and 23, but we're going to include 23. So all of this in here is where 3y minus 7 would be. But that doesn't necessarily tell me about y, right? So I'm going to restate the compound inequality here. So we have 8 is less than 3y minus 7, which is less than or equal to 23. And now, just following the same properties of inequalities, what I do to one side, well, now there's three sides in this. And so what I do to one, I have to do to all three. And I want to get rid of this 7 so I can get closer to finding out what y is. So we're going to add 7 to all sides, plus 7 here and plus 7 here. And 8 plus 7 gives me 15, which is less than 3y, which is less than or equal to 23. Oh, excuse me. That's wrong. 23 plus 7 is 30. All right. So now I can divide all 3 by 3. I'm going to divide everybody by 3 here. I'm going to divide all of them by 3. And 15 thirds gives me 5, which is less than y, which is less than or equal to 10. Okay. So now I know the value of y. And I'm going to plot my answer here on this number line. I'm going to graph on this number line and describe the values that y can be. And I have 0 and 5, and here is 10. Now again, y is strictly greater than 5, so I have an open circle at 5, and it's less than or equal to 10, so I'm going to have a closed dot at 10, and all the values in between are the values for y. And using interval notation, again, parentheses, well, let's make sure those are good parentheses here. Parentheses means not included, so 5 to 10, and 10 is included. So this is our interval answer, or our answer using interval notation. And we want to show our answer using set builder notation as well, and that would be the set of y values such that we have... that 5 looks pretty terrible. We have y between 5 and 10. And we're going to include 10. Really, this is just the answer that we got before, and I'm placing it inside my set builder notation. Okay, so now let's take a look at what an OR compound inequality looks like. Well, here we have 4x plus 3 is greater than or equal to 27, or 4x plus 3 is less than or equal to negative 27. Okay, so on a number line here, we could take a look at, here we have negative 27, here I have 0, and over here I have 27. And it says 4x plus 3 is greater than 27, greater than or equal to 27, excuse me. So I'm going to have a closed dot at 27, and I'm looking at all the values bigger than 27. This describes 4x plus 3. And 4x plus 3 is less than or equal to negative 27. So we have a closed dot at negative 27. And we're going to describe all the values that are less than 27. And again, this describes 4x plus 3. But it doesn't actually tell me what x is. So we need to solve each of these compound, or each of these inequalities that make up the compound inequality. We want to solve each of them to find out what values x can take on. Well, looking at this here, this says 4x plus 3 is less than or equal to negative 27. So we have 4x plus 3 is less than or equal to negative 27. Oops, excuse me. I am struggle bussing with this pen today. Or 4x plus 3 is greater than or equal to positive 27. Okay, we can subtract 3 from all sides here, and I'm going to do both equations or both inequalities at the same time. Now I have 4x is less than or equal to negative 30, and I have 4x is greater than or equal to 24. All right. Now we can continue solving for x by dividing everybody by 4. Divide by 4. Dividing by 4. Dividing by 4. And now I have x is less than or equal to negative, well, 30 and 4 are both even, so they both divide by 2. Well, 30 divided by 2 gives me 15 half, and then 4 divided by 2 gives me half. So I have x is less than or equal to negative 15 halves. Here, when my 4's cancel, I have x is greater than or equal to, and 24 divided by 4 we know to be 6. So now we want to describe those. Well, let's just take a look at what they would look like on a number line first. So we're going to provide our answer as a solution as a graph on a number line. And the only numbers we need, again, are 0 and a couple of others. Well, over here, we have negative 15 halves. Well, that's a terrible 2. 15 halves. And over here we have 6. Now we're going to describe this guy here. So x is less than or equal to negative 15 halves. So I have a closed dot at negative 15 halves, and it's all the values that are less than. So everything that goes to the left. And here we have x is greater than or equal to 6. So I have a closed dot at 6, and we're going to describe all the values to the right of 6. And this, in interval notation, starting with the far left-hand number, should be negative infinity. We cannot include negative infinity. We never do, so it's got to have a parentheses. And we're going to go all the way until negative 15 halves. And we use this bracket here because it's included at negative 15 halves. And then to describe this one, we include 6. And it's going to go all the way until we get to positive infinity. Again, you can never really reach infinity, so it's never really included. And we're going to marry these two with a union. And that union says that x can take on all the values between negative infinity and negative 15 halves, or 6 and infinity. All right, so now let's try this absolute value inequality. And whenever you see this, I don't want you to read the whole thing in there. I just want you to just ignore everything that's in there for now and just say, my distance away from 0 is bigger than 10. Okay, so looking at that on a number line, we can tell pretty quickly with this number line here. Got to get our arrows together. We can tell pretty quickly, so the distance away from 0 being 10, I can take on values between, or I can take on a value of negative 10 or positive 10. These are the two distances away from 0 that are 10. Now, I want my distance away from 0 to be bigger than 10. So over here at negative 15, for example, is negative 15 further away from 0 than 10? Well, sure it is. So everything over here, and we're going to have an open circle, these numbers all describe 3x minus 4 that are less than negative 10. And here, I'm going to have an open circle at positive 10. And I want my distance away from 0 to be bigger. So my distance away from 0 to be bigger would be everything over here. And this is describing 3x minus 4. Now, I have two sets of numbers that I'm trying to describe. So when I put my compound inequalities together, this looks like an OR compound inequality. So I need to set up two inequalities. I have 3x minus 4 is less than negative 10, or 3x minus 4 is greater than 10. And now we can solve for x to find out what values x can take on. So we're going to add 4 to all sides. Adding 4 to everybody. And I have 3x is less than negative 6. And here I'd have 3x is greater than 14. All right, and now we're going to divide everybody by 3. Dividing by 3, divide them all by 3. I get x is less than negative 2, or x is greater than 14 thirds. Because 3 doesn't go into 14 evenly, I know that I can just leave that as my improper fraction. Well, let's graph these solutions on a number line. And when we do that, I'm going to have a 0. And the other number I need is a negative 2 and a positive 14 thirds. Okay, so x has to be less than negative 2, so I'd have an open circle at negative 2, and I'm going to describe all the values to the left, which are less than negative 2. And here I have open circle at 14 thirds, and I'm going to describe all the values that are greater than 14 thirds. All right, so we've graphed our solution here. Now, using interval notation, again, I want to go from negative infinity until I get all the way to negative 2. I'm not including negative 2, so I have those parentheses. And I'm going to marry these two sets with a union. And another parentheses because I'm not including 14 thirds. And I'm going to go all the way until I get to infinity. So using interval notation, we can describe our solutions here. And in set builder notation, it's the set of all x values such that x is less than negative 2 or x is greater than 14 thirds. And close our set. Again, look, I just used my answer here for set builder notation.